This engine had a narrow power band and was not very tractable for road use when coupled with the close ratio gearbox that it had. These engines are becoming jewels now. As time goes on, there are less and less of them. And to make them more tractable, one company has been concentrating on this work for a number of years, and the answer lies in the porting of these engines. This company is Omnitech Engineering of Bellingham, Washington. And the founder and owner of this company is John McCoy.
I was restoring a Lotus Cortina, and like all people doing that kind of a project, you have to find bits and pieces. And cylinder head was one of the things we were in the hunt for. And further, I complicated it by wanting to do a street race car version, which further complicates the whole thing. The cylinder head in itself, being hemispherical, leads itself to more of a horsepower motor than it does a torque band motor, and we need a wide torque band to really run in a Lotus Cortina. The fact that the Lotus Cortina was heavy further made it more complicated. After I looked at this hunk here, that both the head, Stromberg head and the Weber head was basically the same design minus the ports. So that got me to thinking that maybe we ought to just take and weld a manifold onto a Stromberg head or something like that to come up with a Weber head. Kind of led to the discovery that once the manifold is removed, the first 2 inches of the port are easily accessible, and that's the most critical element of the port to establish this broad band of power that we were after. Use this exact manifold on a head to step into flow bench analysis, studying the balancing of the head, which is very critical for a broadband engine. The air in this area right here is the most compressed. If you can just imagine the airflow coming down and into the cylinder, it's the most compressed. So the shape of this per port has to be very precise and repeated. So if you can imagine on an original Weber head, like this is a section of one, trying to reach down in here with a die grinder, bouncing it around, trying to get this size exactly the same per port was a real challenge. So it wasn't unlikely that you would end up with a really good head and a really crappy head and an in-between head. And, it was a real toss. So that further justified the possibility of removing the manifold to get in and with the CNC and very precisely port this part of the port, and that gave us repeatability. Of course, it was torque came in at 3500. That engine and cylinder head still to this day is running in my Lotus Cortina. So we really did hit the mark. More importantly, though, from those early dyno test numbers, I was able to then integrate those into computer analysis and computer simulation. So now I had a baseline to do further tweaking with the port and the flow bench based on that original curve. In seconds with the computer simulation, I could tell if I was going to be able to create something very easy to make horsepower out of a twin cam. You just open the ports up massively, put big valves in, big cams in, and they just zoom up and make all kinds of horsepower. But that engine would be referred to in historical terms as a peaky engine. It doesn't have anything down at the low end. So the Lotus Cortina was a perfect test bed. A formula engine is real easy to build compared to a heavy engine or heavy car. once you have a baseline, that's critical. You need a real-time, real figure baseline off of our actual dyno. But then we can use, there's 3 or 4 different versions of software I use, and I compare them to each other off of a known baseline. And then I can estimate what an engine is going to do in seconds compared to having to build a motor and put it on a dyno and test it and prove it out. It's just a very long, drawn, complicated process that way. Analysis off the flow bench, computer simulation. Some of those developments are more mature than others. I would say the Stromberg-Weber conversion is probably the most mature as far as knowledge gained. But all those developments are a baseline, and if I'm asked to build an engine again, I can go back and look at those dyno numbers and estimate. I'm always tuning the engine or thinking about other things I could or couldn't done to a particular motor as I'm driving, and noting early torque or late torque or what I didn't like or didn't like. I've got a short version of the Stromberg-Weber conversion now I'm playing around with. It's just showing incredible results. Just from a hand tooling issue, it's hard to reach with the die grinder that far down and have any accuracy whatsoever, which is very critical because this has to repeat per cylinder to get the adequate, flow. You're trying to balance the intake to the exhaust for flow very precisely. So the end result really of these heads was that some heads were really, really good and some heads were just crap. And it really came down to how accurate a fellow could port this intake short term. Where the manifold being removed was really the essence of the project, because with that removed, and particularly with the CNC, I can come in here very accurately and repeat this very critical part of the port, and then put this back on, and you have a very accurately done head. I kept careful track of the shape of that in the CAD system, and then repeated that same shape through every single one of the ports. That head and that engine made 190 horse, and the torque came in at about 3,500, and that engine to this day is in my Lotus Cortina. It drives like it's fuel injected on the street, and it goes like a stink on the track. Up after the first motor was dynoed, because then I had an actual dyno pull and curve that I could take any computer simulation and tweak the curves within that simulation to match it. Then if I wanted to change valve timing events within that simulation, I could see the results in seconds.